Modular arithmetic. Modular arithmetic is a system of arithmetic for integers where numbers wrap around a certain value. It is an arithmetic with integers. The numbers are wrapping around in a certain value. You see this clock we always used in our house, isn't it? In this clock, we know that in one day is 24 hours, but in the clock, only 1 to 12 numbers are there. For showing the 24 hours, the clock only having 1 to 12. While the needle hitting this 12, it again goes to 1 automatically. So 24 hours can be splitted into 1 to 12. Again it is 1 to 12. So totally 24. When it is hitting 12, it again goes to 1. Like that, the numbers are wrapping around certain values. It is called modular arithmetic. We use the numbers 1 to 12 to represent the time period of 24 hours. Then, Carl Friedrich Gauss. The idea of modular arithmetic was developed by this Carl Friedrich Gauss. So he is hailed as the prince of mathematicians. Then congruence modulo. Two integers a and b are congruence modulo n if they differ by an integer multiple of n. The difference between the two integers is an integer multiple of n. That we can write it as a minus b is equal to some integer multiple of n, that is k into n. It is similarly, we can write like this: A is congruence. The three lines shows that it is congruence. A is congruence to B mod n. This means A minus B is divisible by n. Okay, A minus B is divisible by n. That or A minus B is some multiple of integer multiple of n. The same meaning only. A minus b is divisible by n. For example, 61 is congruence to 5 mod 7. When you are taking this 5 is the remainder. When you are dividing this 61 by 7, the 5 is the remainder. Here also A is congruent to B mod n. That means B is the remainder and n is the divisor. When you divide this, dividend is A. When you divide A by n, you get the remainder is B. So only A minus B is a multiple of n or divisible by n. Here also 61 is congruent to 5 mod 7. So when you are taking 5 on left side, 61 minus 5, that is 56. 56 is divisible by 7. We know that 7 sevens are 49, 8 sevens are 56. So it is divisible by 7. Then next, one illustration. The first one, you have to find the value of 8 mod 4. That means you have to divide 8 and write the remainder. The remainder here is 0, isn't it? 4 is a divisor of 8. So when you are dividing, you get the remainder is 0. When the divisor is 4 means the possible remainders are 0, 1, 2, 3. Some working condition will be there when you are writing this 0, 1, 2, 3 in clockwise direction. 0, 1, 2, 3 in clockwise direction and count 8. The value of 8 we want to find it, isn't it? So you have to count 8 times. So 0 to 1, that is 1. Here it is 2. Then 3. Again 0, 4. again 1, 5, again 2, 6, again 3, 7, again 0, that is 8. So you get the value of 8. 8 is congruent to 0 mod 4. In the similar way, we can find like this. The divisor is 4. So when you are dividing 8 by 4, you get the remainder is 0. So we can write it as 8 is congruent to 0 mod 4. Then illustration 2, we have to find out the negative number minus 5 mod 3. Here it is negative value is coming. So we know that the remainder is not negative. Here mod 3 means the possible reminders are 0, 1, 2. So you have to write in clockwise direction 0, 1, 2 and count minus 5. So anti-clockwise direction you have to count 5. Minus 5 means in the anti-clockwise direction you have to count from 0 to 2, that is 1, 2 to 1, that is 2, then here it is 0, 3, again 1, 4, again 2, 5. So you get 5. 5 is the answer for minus 5. Minus 5 is congruent to 1. The 5 shows it is 1. So minus 5 is congruent to 1 mod 3. How will you get this on without drawing such figure? See that when you are dividing 5, positive value of 5, that is when you divide it by 3, you get the remainder is 2, isn't it? So when you are getting the remainder is minus 2, you have to subtract the divisor from the remainder. The divisor here is 3, isn't it? So subtract the remainder from this divisor. So you get 3 minus 2. So minus 5 is congruent to 1 mod 3. The same answer you get. Okay children, you have to just divide, you get minus sign. So you have to subtract the remainder from the divisor, that is 3 minus 2, you get the same answer. Then connecting Euclid division lemma with modular arithmetic. Euclid division lemma in the previous section you have learned, isn't it? M and n are two integers and m is positive. Then Euclid division lemma, we can write it as n is equal to m cube plus r, where 0 less than or equal to r less than m. We can connect this one with modular arithmetic. We take this r on left hand side. Here n is congruent to r modulo m. That means we can write it as n minus r. You take this r on left hand side. N minus r is equal to m cube. That means n minus r is a multiple of m. That means it is divisible by m and the remainder is 0. So we can write it as n minus r is congruent to 0. 0 is the remainder when divided by m, mod m. We can write like this. When you are taking r on right hand side, you get n is congruent to r mod m, where r is the remainder and m is the divisor. Okay children, so it is connected with modulo m. Thus the equation n is equal to m cube plus r through Euclid division lemma can also be written as n is congruent to r mod m. The same line can be written as n is congruent to r. R is the remainder. N is congruent to r mod m. Then one note is there, two integers a and b are congruent modulo m. We can written as a is congruent to b mod m if they have the same remainder when divided by m. When divided by m, if a and b leave the same remainder, we can say that a is congruent to b modulo m. Then modulo operations. two theorems will be there. We can apply the theorem for doing problems. So children, carefully you have to learn the theorems. Only statement. If A is congruent to B mod M and C is congruent to D mod M, then we can write like this. You can add these two, we can consider it is two equations and add the left hand side and the right hand side. So A plus C is congruent to B plus D mod M. Also we can subtract A minus C equal to B minus D mod M. And also we can multiply A into C is congruent to B into D mod M. So such a result we can apply for doing problems. Okay. Some examples will be there. If 17 is congruent to 4 mod 13 and 42 is congruent to 3 mod 13, we can apply this result. See, this 17 plus 42 is equal to 4 plus 3 mod 13. 17 plus 42 is 59. 59 is congruent to 7 mod 13. When you are dividing this 59 minus 7, what do you get? 52. 52 is divisible by 13. So hence the result is true. Like that, 17 minus 42 is equal to 4 minus 3. While subtracting, you get minus 25. Here you are getting 1. While dividing, when you are taking this 1 on left hand side, minus 25 minus 1 equal to minus 26. It is divisible by 13. Then the third one, 17 into 42 is equal to 4 into 3. 17 into 42 is 714, which is congruent to 4 3s are 12. While subtracting, what do you get? 702. It is divisible by 13. These are the examples for this theorem. Then theorem 6, what it says? If A is congruent to B mod M, then C is any integer. Then we can multiply both the sides by C. A into C is congruent to B into C mod M. Like that, the same integer we can add or subtract both the sides. If you are adding, both the sides you have to add. You are subtracting, both the sides you have to subtract. So it is written as A plus or minus C is congruent to B plus or minus C mod M. Let's see the examples in the next video. Okay.